A horizontal throw is 4 meters long and 1 meter deep. Its cross section is an isosceles triangle of a base 1.5 meters with its vertex, so its corner, downwards. Water runs into the throw at a rate of 0.03 meters cubed per second. Find the rate at which the water level is rising when the water has been running for 25 seconds. So it's best to draw out a picture. So here we have an isosceles triangle pointed downwards with its vertex pointed downwards. It's isosceles, which means that it has two equal sides, two equal lengths, and then two equal angles. So the base of the triangle, which is along here, is 1.5 meters long, and half of 1.5 meters is 0.75 meters. So from here to here is 0.75 meters, and from here to here is 0.75 meters. So the grey colour is the water filling at the bottom. So the water is coming into the throw, it's filling the bottom of it, and it's rising. And this is the vertex. This is the bottom of it. So this is where it's filling and it's rising upwards. So the water runs into the throw at a rate of 0.03 meters cubed per second. So that's the rate at which the water is going into the throw. And we want to find the rate at which the water level is rising when the water has been running for 25 seconds. So we want to know the rate at which the water level is rising. So what's been given? Well, dv dt has been given. So the derivative of v with respect to t. So you didn't have to call it v as such, you could have called it any letter, but t would stand for time. So water runs into the throw at the rate of 0.03 meters cubed per second. So dv dt, the derivative of v with respect to t, time, is 0.03. We want to find dh dt, the derivative of h with respect to time, with respect to t. So h is this distance here. So we're interested in the rate at which this is filling after 25 seconds. Also note that this is 1 meter. That again was given to us in the question. We were told that the throw was 1 meter deep. So that's 1 meter. So we want to find dh dt. So dh dt is dv dt multiplied by dh dv. So notice that we just put dv as a numerator and dv again as a denominator. So since we've multiplied above and below by the same thing, we haven't actually changed the value of it. So dv dt multiplied by dh dv is the same thing as dv dt divided by dv dh. So we change a multiply to divide, and we flip dh dv upside down to get dv dh. So dv dt divided by dv dh is the same thing as dv dt divided by dv dh. Okay, so if you look at your isosceles triangle again, and you just take the left-hand side, so we see if we cut the triangle in two, we have a right angle triangle, and we have a smaller right angle triangle inside of it. So we have our parallel lines, the green and the yellow, and then the bigger triangle's height is in purple, and the smaller triangle's height is in blue. So we have similar triangles. So similar triangles are similar, they're not the same. So they have three angles that are equal, but their sides are different length, but they are in proportion with each other. So similar triangles are similar, they're not the same. So this smaller triangle has the exact same angles as the bigger triangle, but the lengths are different, but the lengths are in proportion with each other. So we're going to set up an equation in terms of x and h. So we're going to take the smaller triangle's parallel side. So what is parallel to the green triangle? Or you could call it its base. That's going to be our numerator. And that's going to be divided by the corresponding side on the bigger triangle, which is going to be 0.75. And that's equal to the height of the smaller triangle, which is going to be h, divided by the height of the bigger triangle, which is going to be 1. So you could have wrote it the other way around. So you could have had 0.75 on the top and x on the bottom, and 1 on the top and h on the bottom. You'd still get the same answer. So long as you have for example, the smaller triangle's measurements as the numerators, and the bigger triangle's measurements as the denominators, or vice versa. So now we have set up our equation, we can solve. So we cross multiply, so x times 1 is x, and 0.75 times h is 0.75h, and 0.75h is the same thing as 3/4 h, or 3h over 4. So x is equal to 3h over 4. Then the area of the triangular base of the water is, so area of a triangle is half times base times height. This comes from page 9 of our formula book. So the area is going to be half times the base, which is 2x. So x plus x is 2x, times the height, which is h. So here's our height h, which is also here. So half of 2x is x, and h just stays the same. So the area of the grey triangle at the bottom can be written as x times h. Well, we know that x is equal to 3h over 4. That was on the previous slide. So just go back a few seconds to see where that came from if you're unsure. And 3h over 4 times h is 3/4 h squared. So the area of the triangular base, so the grey triangle, is 3/4 h squared. So V, which is the volume of the prism, is going to be A times h, because this comes from our formula on page 11 for a prism, the area of the cross section times the height. So the area of the cross section is 3/4 h squared, times the height, which will be 4. But in this case, it would actually be the length of the prism. So we know that the throw is 4 meters long. So that's where the 4 is coming from. And 3/4 h squared times 4 is 3h squared. So just to show you, this is page 9 of the formula book. So this is the area of a triangle. A equals a half AH. So half times base times height. And this is page 11 of your formula book, where V is the volume of a prism, is equal to B times H. So B is the area of the base, and H is the height, or in our case, the length. So we know that V is equal to 3h squared. That's from the previous slide. Then dV dH, the derivative of V with respect to H, is going to be 6h, because 3 times 2 is 6, and 2 take away 1 is 1, so we get 6h. Thus, dH dt is dV dt over dV dH, so we got that from the first slide. dV dt, the derivative of V with respect to t, is 0.03, that was given in the question. dV dH is 6h, we just worked that out up here. And 0.03 divided by 6h is 1 over 200h, or 1/200th h. So when the water has been running for 25 seconds, V is equal to 25 times 0.03, which is 0.75. So V, we know, is 3h squared. So 3h squared is equal to 0.75. So dividing by 3, we get h squared equals 0.25. And square rooting that, we get h is equal to 0.5. So dH dt is equal to 1 over 200 multiplied by 0.5, because we've swapped that h there for 0.5 with brackets. We get 1 over 100, which is 0.01 meters per second. So the rate at which the water level is rising when the water has been running for 25 seconds is 0.01 meters per second.